Hello, this lesson is about roots and rational exponents. The most basic of roots you already have learned in middle school. You learned about square roots. You learned that a number squared was simply a number multiplied by itself. So for instance, 1 squared equals 1, 2 squared equals 4, and 3 squared is 9. And when you square each of these numbers, the result is called a perfect square. Being able to identify your perfect squares will make Algebra 2 much easier. So you know that if 8 squared is 64, then the square root of 64 equals 8. To simplify a square root, you simply need to find the largest perfect square that divides evenly into the number. So for instance, the largest perfect square that divides into 27 is 9, and 9 times 3 is 27. The square root of 9 is 3, and the square root of 3 is. When you look at example 2, oftentimes students will select 4 as the largest perfect square that goes into 48. 4 is a perfect square, but it's not the largest perfect square. The largest perfect square is 16. Both of these examples happen to have 3 under the radical, but that won't always be the case. Just keep that in mind. In this next example, we're going to talk about the relationship between a root expression and an expression with a rational exponent. So these 3 examples given are all in root form, and the connection is this. The nth root of a to the nth power is equivalent to a to the n over m. So for instance, in example 1, the third root of x to the 7th is equal to x to the 7 thirds. In the second example, the square root of x to the 9th is equivalent to x to the 9 halves. Fourth root of x to the 8th is equivalent to x to the 8 fourths, which is more simply known as x squared. In this last slide, we can use that same idea that we just used to evaluate. So for instance, we may not know the cubed root of 2, but we know how to rewrite. So we can say, okay, this is equivalent to 2 to the 6th over 3. Squared. In the second example, you can do one of two things. You can either say, I know that 4 to the power of 3 is 64, and the square root of 64 equals 8. Or you can also say that you know the square root of 3 is equivalent to the square root of 4 cubed. I like this method because oftentimes it'll take a large number, and by taking the square root, make it much smaller. Look at this last example. This could be rewritten as 3 to the 12th over 4. These may be examples you want to refer back to as we go on in this first chapter, because all of these concepts will come back again and again as we study quadratic functions.